Hi students, coming to the next protocol, that is in the TCP over ad hoc wireless networks. So in that we are discussing about the end-to-end approach. So in the previous video I explained about the TCP-F, which is a TCP feedback protocol. Now let's see the another protocol, that is the TCP ELFN. So which is an end-to-end approach of TCP over ad hoc wireless network. TCP ELFN means explicit link failure notification. Explicit link failure notification. So what is the use of this protocol? Here it improves the TCP performance in ad hoc wireless networks. So this explicit link failure notification, because of this notification signal, the TCP performance will be increasing in ad hoc wireless networks, and it is similar to the feedback TCP also. Now let's see the operation. So how it is going to be send the explicit link failure notification will identified and sent to the sender, and it will the message will be received by the receiver. Let's see. The explicit link failure notification is originated by the node detecting a path break upon detection of a link failure to the TCP sender. So here this LFN is originated by the node, which is detecting a path break upon detection of a link failure. So this can be implemented in two ways. The explicit link failure notification can be implemented in two ways. So one is by sending destination unreachable message to the sender. Okay, the sender is here and the receiver is here. In between so many nodes are there. Okay, so how this explicit link failure notification will be implemented? It can be implemented in two ways. One is by sending a destination unreachable message to sender. So suppose whenever the link is break, a communication will be break, the sender is receiving an unreachable, that is a destination unreachable message, DUR, destination unreachable message to the sender. Then the sender will understand, okay, the packet whatever I sent, that will not received by the receiver because of the failure. That is the explicit link failure notification, not as is within the region. It is explicit link failure notification can be received by the sender with the help of destination unreachable message, or by piggybanking this information to the sender. So once the TCP sender receives the ELFN packet, once the TCP sender, so whatever the sender is there, receives the ELFN packet, explicit link failure notification, it disables the retransmission timers and enters a standby state. So in this feedback also, whenever it receives an failure notification, the sender is going to be snooze. In the same way here also, in the explicit link failure notification also, whenever it receives that packet, the sender is disables the retransmission timers and enters a standby state. So in this state, it periodically originates probe packets to see if a new route is established. So here the remaining nodes and every node is going to be, that sender is going to be check whether there is any new route is established or not. So upon receiving an acknowledgement by the TCP receiver for the probe packet, it leaves the standby state and continues to function as a normal. Okay, so whenever it finds a new route establishment, upon reception of an acknowledgement by the TCP receiver, so whenever by finding the new route, whenever the packet is sent to the receiver will send with a acknowledgement message. So whenever the sender receives the acknowledgement from the receiver for the probe packet, it leaves a standby state and continues to function as a normal. Until it receives the acknowledgement, the sender is in standby state. It won't send the packets again. It will remain in a standby state. So the lost packet, the remaining nodes will check for the another new route which is established and send those packets to the receiver side, and the receiver will be acknowledged to that probe packet. So this is how the operation of the explicit link failure notification of TCP. Now let's see what are the advantages in this. The advantages are it improves the TCP performance by decoupling the path break information from the congestion information by the use of ELFN packets. Okay. And less dependent on routing protocols. So here it is this ELFN is less dependent on routing protocols and requires only link failure notification about the path break. So it just requires a link failure notification about the path break. Then what are the disadvantages in this? When the network is temporarily partitioned, the path failure may last longer, and this can lead to the origination of periodic probe packets consuming bandwidth and the power. So because of that reason, it is consuming bandwidth and power. And the congestion window used after a new route is obtained may not reflect the achievable transmission rate acceptable to the network and the TCP receiver. So whenever the path break is there, so a new route is obtained. So with the establishing of the new route, it may be there is a reflect in the achievable transmission rate acceptable to the network and the TCP receiver. Thank you.